The electrical code does allow a 15-amp circuit to be used for a dishwasher location. According to the National Electrical Code 2023, a dishwasher must be connected to a dedicated 120-volt, 15-amp circuit. The circuit can be either a 14 or 12 American wire gauge wire. A grounded conductor and equipment grounding conductor must also be used. The National Electrical Code allows 15-amp circuits for dishwasher locations because most dishwashers draw less than 15 amps. Typical dishwashers draw around 10 to 12 amps during normal operation. Dishwashers are not typically used for extended periods, reducing the likelihood of overloading the circuit. Dishwashers are often used during off-peak hours when other appliances are not in use, minimizing the risk of tripping the breaker. Most kitchens have a dedicated panel with a specific capacity. Using 15-amp circuits for dishwashers allows designers to maximize the number of circuits available for other kitchen appliances. While the National Electrical Code allows 15-amp circuits for dishwasher locations, it is important to consider the following factors. Some high-end dishwashers may draw more than 15 amps, requiring a 20-amp circuit. In kitchens with numerous appliances, it may be necessary to upgrade to a 20-amp circuit for the dishwasher to ensure reliable operation. Also be aware of local code requirements, as some local jurisdictions may have specific requirements that differ from the National Electrical Code. In most cases, a 15-amp circuit is sufficient for spec house dishwasher location, but it's always advisable to consult with a qualified electrician for proper installation and safety considerations. Firstly, the National Electrical Code, or NEC, serves as the cornerstone for electrical safety standards in the United States. It's a comprehensive document that outlines the requirements for safe electrical installations. It covers everything from wiring methods to overcurrent protection, grounding, and equipment installation. Secondly, the NEC is updated every 3 years by the National Fire Protection Association, or NFPA, to incorporate new technologies, address emerging safety concerns, and improve existing regulations. This ensures that electrical installations remain safe and reliable as technology advances. Thirdly, the NEC is not a law itself, but it is widely adopted by state and local jurisdictions, becoming the legal basis for electrical inspections and enforcement. Compliance with the NEC is essential for ensuring the safety of people and property. Now let us discuss American wire gauge, often abbreviated as AWG, which is a standardized system for denoting the size of round, solid, non-ferrous conductors such as copper or aluminum. The AWG number is inversely proportional to the wire's cross-sectional area, meaning that a smaller AWG number indicates a larger wire diameter. For example, a 12 AWG wire is thicker than a 14 AWG wire. The larger the wire, the more current it can safely carry without overheating. The NEC specifies the allowable ampacities for different wire sizes based on their insulation type and installation conditions. Choosing the correct wire size is crucial for preventing overheating, voltage drop, and potential fire hazards. The grounded conductor, often referred to as the neutral conductor, is a critical part of an electrical system. Its primary function is to provide a return path for current to flow back to the source. In a typical 120-volt circuit, the grounded conductor is connected to the neutral point of the power supply, which is typically at or near ground potential. The grounded conductor is usually identified by its white or grey insulation. It is essential for maintaining a stable voltage and preventing electrical shock hazards. The equipment grounding conductor, often referred to as the ground wire, provides a low impedance path for fault current to flow back to the source in the event of a ground fault. This helps to quickly trip the circuit breaker or fuse, interrupting the flow of electricity and preventing electrical shock hazards. The equipment grounding conductor is typically a bare or green insulated wire. It is connected to the metal enclosures of electrical equipment, such as appliances, lighting fixtures, and electrical panels. Proper grounding is essential for electrical safety. Overloading a circuit occurs when the total current drawn by all the devices connected to a circuit exceeds the circuit's rated ampacity. This can happen when too many appliances are plugged into a single circuit or when a high-power device is used on a circuit that is not designed to handle it. Overloading a circuit can cause the wires to overheat, potentially leading to insulation damage, electrical fires, and equipment failure. Circuit breakers and fuses are designed to protect circuits from overloading by interrupting the flow of electricity when the current exceeds the circuit's rating. Using appliances during off-peak hours, such as late at night or early in the morning, can help to reduce the load in the electrical system and minimize the risk of tripping the breaker. This is because overall demand for electricity is low during these times, so there is less strain on the grid. Off-peak hours can vary depending on the utility company and the region. A dedicated electrical panel is a distribution point that houses circuit breakers or fuses that protect individual circuits in a building. Each circuit breaker controls the flow of electricity to a specific area or appliance. Dedicated panels are typically used in kitchens, bathrooms, and other areas with high electrical demand. They provide a centralized location for managing and protecting electrical circuits. Kitchen size and appliance usage play a significant role in determining the electrical needs of a kitchen. Larger kitchens with numerous appliances such as refrigerators, ovens, dishwashers, and microwaves require more circuits to handle the increased electrical load. It may be necessary to upgrade to a 20-amp circuit or even a larger service panel to ensure reliable operation and prevent overloading. High-end dishwashers may draw more than 15 amps, requiring a 20-amp circuit. Always consult the manufacturer's specifications to determine the current requirements of the dishwasher. Local code requirements can vary from the National Electrical Code. Always check with the local building department to ensure compliance with all applicable codes and regulations. Consulting with a qualified electrician is always recommended for any electrical work. An electrician can assess the electrical needs of the home and ensure that all electrical installations are safe and code compliant. Now let's discuss some additional considerations for dishwasher circuits. Firstly, the distance between the electrical panel and the dishwasher location can impact the voltage at the appliance. Longer wire runs can result in voltage drop, which can affect the performance of the dishwasher. To minimize voltage drop, it may be necessary to use a larger wire size. Secondly, the type of wiring used for the dishwasher circuit can also affect its performance. Non-metallic sheath cable, or NEC cable, is the most common type of wiring used in residential construction. However, in some cases, it may be necessary to use conduit to protect the wiring from physical damage. Thirdly, the location of the dishwasher relative to other appliances can also impact the electrical load in the circuit. If the dishwasher is located near other high-power appliances, such as a refrigerator or oven, it may be necessary to upgrade to a 20-amp circuit to ensure that the circuit can handle the combined load. Fourthly, the age of the electrical system can also impact its ability to handle the load of a dishwasher. Older electrical systems may not be able to handle the increased electrical demand of modern appliances. It may be necessary to upgrade the electrical system to ensure that it can safely and reliably power the dishwasher. Fifthly, it's important to consider the energy efficiency of the dishwasher when determining the appropriate circuit size. Energy-efficient dishwashers draw less power than older models, so they may be able to operate safely on a 15-amp circuit. However, it's still important to consult the manufacturer's specifications to determine the current requirements of the dishwasher. Sixthly, consider the potential for future upgrades or additions to the kitchen. If there is a possibility of adding more appliances or increasing the electrical load in the future, it may be wise to upgrade to a 20-amp circuit now to avoid having to do so later. Seventhly, make sure that all electrical connections are properly tightened and secured. Loose connections can cause overheating and potential fire hazards. Eighthly, always use the correct size and type of circuit breaker or fuse for the dishwasher circuit. Using the wrong size breaker or fuse can result in overloading the circuit or not providing adequate protection. Ninthly, test the dishwasher circuit after installation to ensure that it is working properly. Use a multimeter to check the voltage and current on the circuit. Tenthly, make sure that the dishwasher is properly grounded. A properly grounded dishwasher can help to prevent electrical shock hazards. Firstly, the NEC allows a 15-amp circuit for dishwashers based on the assumption that most dishwashers do not draw more than 12 amps during normal operation. This allowance is rooted in the understanding of typical dishwasher energy consumption patterns. Secondly, the intermittent nature of dishwasher use plays a role in the NEC allowance. Dishwashers are not typically used for extended periods like refrigerators or ovens, reducing the overall demand on the electrical system. Thirdly, dishwashers often operate during off-peak hours, when the overall electrical load on the grid is lower. This minimizes the risk of overloading the circuit and causing a breaker to trip. Fourthly, the allowance of 15-amp circuits for dishwashers enables designers to maximize the number of circuits available in the kitchen panel. This optimizes the electrical infrastructure while adhering to safety standards. Fifthly, in some cases, a 20-amp circuit may be required for dishwashers that draw more than 15 amps or for installations with specific local code requirements. It's important to assess the dishwasher's power requirements and consult with a qualified electrician to determine the appropriate circuit size. Sixthly, the NEC provides guidelines for calculating the load on a circuit based on the types and number of appliances connected to it. These calculations ensure that the circuit is capable of safely handling the expected electrical demand. Seventhly, proper wiring practices such as using the correct wire gauge and ensuring secure connections are crucial for the safe operation of a dishwasher on a 15-amp circuit. These practices minimize the risk of overheating, voltage drop, and other electrical hazards. Eighthly, regular inspection and maintenance of the dishwasher circuit can help identify and address potential issues before they escalate into safety concerns. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. Ninthly, local jurisdictions may have specific requirements or interpretations of the NEC that differ from the national standard. It's important to be aware of these local variations and comply with all applicable codes and regulations. Tenthly, consulting with a qualified electrician is always recommended for any electrical work, including dishwasher installations. An electrician can assess the electrical needs of the home and ensure that the installation is safe, code compliant, and meets the dishwasher's power requirements. For example, let's say you have a spec house kitchen with a dedicated 120-volt panel. The panel has a capacity of 100 amps. The kitchen includes a refrigerator, microwave, oven, and dishwasher. The refrigerator draws 6 amps, the microwave draws 10 amps, the oven draws 20 amps, and the dishwasher draws 12 amps. According to the NEC, a 15-amp circuit is sufficient for the dishwasher because it draws less than 15 amps. However, if the kitchen has numerous other appliances, it may be necessary to upgrade to a 20-amp circuit to ensure reliable operation. Also, consider the potential for future upgrades or additions to the kitchen. If there is a possibility of adding more appliances or increasing the electrical load in the future, it may be wise to upgrade to a 20-amp circuit now to avoid having to do so later. In this case, it's best to consult with a qualified electrician to determine the appropriate circuit size. Another factor to consider is the dishwasher's energy efficiency. Energy-efficient dishwashers draw less power than older models, so they may be able to operate safely on a 15-amp circuit. However, it's still important to consult the manufacturer's specifications to determine the current requirements of the dishwasher. Proper wiring practices, such as using the correct wire gauge and ensuring secure connections, are crucial for the safe operation of a dishwasher on a 15-amp circuit. Regular inspection and maintenance of the dishwasher circuit can help identify and address potential issues before they escalate into safety concerns. A 15-amp circuit can be wired with either 14 or 12 American wire gauge wire. The choice depends on factors such as the length of the wire run, the ambient temperature, and the number of conductors in the raceway or cable. In general, 12 American wire gauge wire is preferred for longer runs or higher temperature applications because it has a higher ampacity than 14 American wire gauge wire. The NEC provides tables that specify the allowable ampacities for different wire sizes based on these factors. It's important to consult these tables to ensure that the wire size is adequate for the application. It is also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the appliance is less than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause the appliance to operate inefficiently or not at all. The NEC recommends limiting voltage drop to 3% for branch circuits. To minimize voltage drop, it may be necessary to use a larger wire size or shorten the wire run. A grounded conductor or neutral wire is required for a dishwasher circuit to provide a return path for current to flow back to the source. The grounded conductor is typically white or gray in color and is connected to the neutral busbar in the electrical panel. An equipment grounding conductor, or ground wire, is also required for a dishwasher circuit to provide a path for fault current to flow back to the source in the event of a ground fault. The equipment grounding conductor is typically bare or green in color and is connected to the metal enclosure of the dishwasher and to the grounding busbar in the electrical panel. The equipment grounding conductor helps to protect against electrical shock hazards. In summary, the electrical code does allow a 15-amp circuit to be used for a dishwasher location, but it's important to consider several factors, including the dishwasher's power requirements, local code requirements, and proper wiring practices. Consulting with a qualified electrician is always recommended to ensure that the installation is safe and code compliant. Remember that electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock hazards. Always turn off the power at the circuit breaker before working on any electrical wiring, and never work on electrical wiring if you are not qualified to do so.